Okay, so I saw a lot of questions yesterday on trying to determine uh, what is going to be the precipitate in double replacement reactions. So the first thing that we need to do is we need to get out this sheet. This is the one that I gave to you last Thursday, um, or you can also find it on Google Classroom. And we need to look at the back page of it. All right, when we turn it over, we're going to get. Oh, well, sorry about that. We're going to get this general rules for predicting solubility of ionic substances. Um, this is what I want to take a moment and look at here. Okay, so these are a set of rules trying to determine what is going to be soluble and what is going to be insoluble. So, first of all, remember soluble means will dissolve. Insoluble means will not dissolve or is a solid, right? Okay, so let's look at a few of these rules here and make sure that we're good on this. So, like I said last week, sorry, just a second here. Like I said last week, 1 and 2 are the most important. These are the ones that you guys should know. Um, the rest of them, you could always look at the sheet. Of course, right now you can look at the sheet for any of them. But 1 and 2 are the most common that we have to worry about. Okay. So once again, reminder also here on this all over the place here, the word salt. We see this a ton of places, right? Salt basically equals ionic compound, right? So anything that's an ionic compound we can think of as being a salt. Okay, so let's look at a couple of these. So the first one, the common salts of the group 1A metals and of the ammonium ion are soluble. So group 1A and ammonium, right? So both of these are cations. So these would be what we're looking at first. So some examples of rule 1 would be things like potassium sulfate, potassium being a group 1 metal, NaCl, sodium being a group 1 metal, ammonium chloride, ammonium, right? So all of these would dissolve in water. All of these are soluble. Okay. So let's take a look at rule 2. The common salts containing nitrates are soluble. So nitrate's an anion. So we'd look at the back half of the ionic compound to determine if it was soluble. Some examples of this. That's an N, sorry. Barium nitrate. Nitrate, soluble. Silver nitrate, the one that was in the aluminum foil dropper bottle last week. Nitrate, soluble. So these are soluble. These will dissolve in water. Okay, those are really the most important 2 rules. The rest of these we'll take just a second and look at here before we try some examples of this. But those 2 are the most, those 2 are the most important. But look at the rest of these. Number 3, the common salts containing chlorates. So you need to go back to your polyatomic ion sheet if you need to. Chlorates or acetates are soluble. Now, here's where we start getting some of these that have exceptions. So you're going to have to read the rest of this. So these first 2 are all the time, right? If you have a group 1, or you have ammonium, or you have nitrate, those are always going to be soluble. The rest of these have exceptions, which is why we could come back to this solubility chart all the time to look at. Okay. Number 4, the common salts containing chloride, bromide, and iodide are soluble. And then here are some exceptions, right? Lead 2 bromide or silver iodide, mercury 1 chloride, right? These would be exceptions and therefore would be insoluble or would be solids, right? When formed in a double replacement reaction. 5, the common salts containing sulfates. So like the first one that we looked at, potassium sulfate, right? Those are soluble with once again, some exceptions here. Okay. The last two are a little bit more interesting to look at, numbers 6 and 7. So first it says, except for those in Rule 1 for both of these. So if either thing in Rule 1 apply, then it supersedes Rule 6 or 7 here. Okay, so when we look at Rule 6, except for those in Rule 1, salts containing carbonates, sulfides, or phosphates are insoluble, meaning they would form a precipitate, right? But if we had something like, let's say, sodium carbonate, right? A carbonate, it said, would be insoluble, but since it's sodium carbonate, that's from Rule 1, so that means that this would be soluble. This would be an aqueous solution. Okay, same thing with sulfides and phosphates. And then the last one, right, except for those in Rule 1, and those in Group 2, the metallic hydroxides or oxides are insoluble. So something like iron oxide, also known as rust, right, would be a solid, okay, because it's an oxide and it's not one of these two. On the other hand, something like magnesium hydroxide, those in group 2, hydroxide, this would be aqueous. Okay, see what we're looking at here on these. So let's put this into action here on a couple of double replacement reactions real quick. Let me clean off all of this, and then let's look at a couple of these here. Well, actually, you know what? Before we do that, let's just take a second, see if we can figure out a couple of these. Calcium sulfate. Okay, maybe you can pause after each one of these, see if you can figure it out, and then we'll go over it. So calcium sulfate. All right, so I see a sulfate here. So I'm going to look at and I also see calcium. We can kind of go through this whole thing. After you go through it a couple of times, you'll start to look at these. Look at the big bold-faced words, obviously. Okay, but I see a sulfate. The common salts containing sulfate are soluble. We've got some exceptions. Barium, strontium, lead, calcium, silver, mercury 1 are notable exceptions. So calcium sulfate, this is insoluble. This would be a solid. Okay. How about something like copper nitrate? Having trouble writing those ins today, sorry. Copper nitrate. All right, let's see, we've got copper and we've got a nitrate. Oh, this should be a sign right here. Whenever you see whenever you see nitrate, you can think this is aqueous, right? Rule 2, the common salts of nitrates are soluble. All right, how about magnesium sulfide, MgS, magnesium sulfide? All right, I remember seeing the sulfides somewhere here. All right, let's see. Magnesium sulfide. Here, sulfides, right here. Except for those in Rule 1, salts containing carbonate, sulfides, and phosphates are insoluble. So that means this is a solid. Okay, so just looking through these, looking at each one of these rules and looking at the bold-faced words and seeing which one is going to apply. Okay, let's do two examples of double replacement reactions here, and let's see if we can figure out what's going to happen. Okay, so let's start out with cobalt 2 nitrate, which is aqueous, it's a nitrate. All right, reacts with sodium hydroxide. Sodium, so we know that it's going to it's going to be aqueous. All right, so we know we're going to switch our cations here, shall we say? So one of them, if we switch these, we're going to end up with sodium. Oh, sorry. Sodium nitrate. And here's cobalt 2 hydroxide. So cobalt, and we can see it's got a +2 charge because there's two negatives on this one. So cobalt 2 hydroxide here. Right. First of all, we can make ourselves happy and we can balance this. There we go. But now let's determine if either one of these are going to be soluble. Right? Or either of these are going to be insoluble. All right, let's look at the first one. Sodium nitrate. Oh boy, that hits both rule 1 and 2. Right? Sodium's a group 1 metal. Nitrates here from number 2. So this is definitely aqueous. Our last one, cobalt 2 hydroxide. Oh, I remember seeing hydroxide someplace. Let's go through here. Down to rule 7. Except for those in rule 1 and those in group 2, the metallic hydroxides or oxides are insoluble. Okay, so cobalt is a transition metal, so it's not group 1 or group 2. So that means this is our solid. This is our precipitate. So that means this reaction would happen. If we put those together, cobalt 2 hydroxide would form a solid and would fall out of solution and would form the precipitate on the bottom. Let's try one more here. Let's do iron 3 chloride, right? And this is not one of the notable exceptions. So iron 3 chloride is aqueous. And copper 2 nitrate. Nitrate is a negative or a nitrate, so rule 2 there, we know that it is an aqueous solution there. All right, so let's see. First, we need to switch our cations here, so we would end up with copper 2 chloride and iron 3 nitrate. Oops, sorry, iron 3 nitrate. Okay, so let's check the solubility of both of these. Copper 2 chloride. All right, chlorides coming up here to rule 4. Some common salts containing chloride, bromide, or iodide are soluble. And there are some exceptions up here. And copper is not one of those exceptions. So that means this one is aqueous. The last one, iron nitrate. Oh, nitrate. We know all nitrates are. So that's going to be aqueous as well. Well, they're both aqueous. So if I put these two aqueous solutions together, iron chloride and copper nitrate, I put them together, when the ions rearrange, both of the products are also soluble. So this is where we would not even have to worry about any of this. We would just say no reaction. All right. Let me know what questions that you have on this.